Hello and welcome to the second part of Materials and Resources video, in which we will be discussing the remaining prerequisite and the full credit related to healthcare only. Prerequisite number 3 is PBD, source reduction of mercury. Now what is PBD? It is persistent, bioaccumulative and toxic material. We can see the pattern in which LEED is trying to focus a bit more on the vulnerables of the society, that is patient in case of healthcare projects and kids when it comes to the school projects. So the measures taken by LEED into these buildings are a bit more stringent. So the intent of this prerequisite is to reduce mercury containing products and mercury release through product substitution, capture and recycling. The purpose sole of this prerequisite is to try to minimize the use and to phase them out completely, the mercury used products. So the requirement is to identify the types of mercury containing products and to how they will be collected and how they will be recycled. The regular stuff or the products that use mercury are HID lamps, compact fluorescents, dental waste, scrap amalgam, etc. Now you have two options: either you're going for a new construction or you're going for a major renovation. In healthcare facilities, they are not allowed to use, if it is a new construction project, they cannot use mercury containing equipment. Only the lamps are excluded from here, and we will see in the credit how. But for the new construction, completely the use of mercury containing equipment is banned. In case of renovation, if you recall, is similar to the refrigeration management. If you are going for the new construction, CFCs are completely banned. But if you are going for a renovation project, there should be a phase out plan. So here's same concept, that you have to plan the phase out of mercury containing products, and you have to or try to upgrade lamps to low mercury than the regular containment of the mercury. So the documentation is to provide existing inventory and phase out plan in case of renovation project. Recycling plan, because you can see in the requirement you have to mention how they will be collected and recycled, and USGBC PBT source reduction calculations. So we have understood that here they are trying to minimize the maximum minimization of usage of mercury. Respective credit number 6 for PBD source reduction mercury, and it's going to give 1 point to the healthcare facility projects. Intent similar. Requirement is to specify and install fluorescent lamps. Now previously in the prerequisite was trying to minimize the use and phase out plan. In here we have to specify and install fluorescent lamps with low mercury, because the hospital equipment, the hospital lighting use may require mercury lamps. So you have to mention that it is low mercury lamp and long life, and it must meet listed lamp life requirement for both existing and new mercury lamps. So it should be low or mercury free. For the documentation, lighting schedule with lamp type, you remember that only lamps were exempted in the new construction projects. So lighting schedule with lamp type, varied hours and mercury content, which is very important when it comes to the credit requirement, and narrative explaining lamps that are excluded from the credit. Credit number 7, PBT or persistent bioaccumulative toxic source reduction. Previously it was for mercury, now it is focusing on lead, cadmium and copper, because there are some health issues associated with these three particles as well. So 2 points for healthcare projects only. The intent is to reduce the release of these chemicals associated with life cycle of the building. Now the requirement is either you eliminate or you reduce the use of lead in piping used for water intended for human use. You use lead and copper piping. So any piping used for water intended for human use, if lead is used in the roofing materials, and we know that lead is used in wire and cables, so you have to substitute them by the material that is either lead free or use less than the required standard. You can also find in paints, as in cadmium, you can see that no use of cadmium and lead is allowed in paints. So green seal certification is a third-party certification that assures that no use of cadmium and lead is there in the paints. For the copper, it is widely used for a supply of water inside the building. So when you make the joints, there is a possibility of contamination in the water, and the copper pieces or the copper contamination can be there. So you have to reduce or eliminate completely the joint related sources of copper. What can you do? By replacing the joints by mechanically crimped copper joints. So the documentation is manufacturer's data or proof explaining excluded materials, and description of pipe joint process in case of copper, and verification of disposal of wires, which we saw in the lead part, or in the lead free or less than required standards, and lead stabilizer. And this is for renovation projects, because in the renovation projects there might be wires and cables that were already installed, but for the new ones you have to go for less lead free or less than the required standards. Credit number 8, furniture and medical furnishings, which are not similar to the furniture used in the other projects. You can gain 1 to 2 points in healthcare only, and the intent is to to enhance environment and human health associated with the freestanding furniture. Now, if you can recognize some of this furniture that you have seen in the medical facilities, the first one is the surgical bed, second is the supply cart, the third one is the transfer aid sort of thing, and the last one is the overbed table. So the requirement is the team must use 30%. If they're using 30%, they will gain 1 point, or 40% for 2 points by cost that meet criteria in 3 options. Now let's go through the options. Minimal chemical content, the similar concept that they are trying to minimize or to reduce as much as they can any chemical content that is harmful for the patients and the vulnerables. So all components of furniture more than 5% by weight must contain less than 100 parts per million of at least 4 of the following. Now these are all technical terms. You just have to learn how much percentage should be out of it. And if you go for why urea formaldehyde is toxic or not fit to use in the furniture, this is a completely different topic. So you have to remember that out of these you should check, or you should comply with 4. This is urea formaldehyde, heavy metals, mercury, cadmium, we already discussed that they are harmful, hexavalent chromium, added antimicrobial treatments, stain and non-stick treatments. So this is option number 1. You have to meet the criteria by cost in one of the in these 3 options. If you are meeting 30%, you'll get 1 point. If 40%, 2 points. So let's see the other 2 options. In option number 2, the categories remain the same, the one we have seen in option number 1, like formaldehyde and heavy metals, cadmium, mercury, etc. But there the constraint was 5% by weight, and you have to meet 4 criteria. But here you have this must contain less than 100 parts per million of at least 2 out of 5. And new furniture and assemblies must be in accordance with these standards. I know it gets a little boring because we cannot discuss the standards here, but you have to remember these standards. For option number 3, products that meet criteria of any one of CR301 or CR402, both by cost. So CR3 was building product disclosure optimization, environmental product declarations, and CR402 was building product disclosure optimization, sourcing of raw materials. But if you remember, the option number 1 in environmental product declaration was based on number of products, but here it is to be based on cost. So in the EPDs, to put things easier in the flow chart, for the self declaration is 1/4. The valuation factors are same, but now it will be applied as in cost. So for option number 2, bio-based materials, material reuse, we have discussed it in detail. So we have to follow these numbers here. So whenever it comes to the cost, do not forget the valuation factor, which is 200%, or valuation factor of 2 when it comes to the products that are sourced, harvested, and transferred within 100 miles of the radius of the project. The furniture and medical furnishings cannot be used in the other BPDO credits, and vice versa. You cannot use the other products in here. Compliance, the good thing is that option 1 compliance and option 2 compliance and option 3 compliance can be put together, and it can give you a total percentage to earn the number of points required. The medical furnishing calculators and documentation of product claims for the criteria must be submitted as documentation, and for the exemplary performance of 1 point, if you can select or comply 50% by cost, it will give you an extra bonus point of 1. Credit number 9, design for flexibility 1.4, healthcare only. This one is interesting. The intent is to conserve resources associated with construction and management of buildings by designing for flexibility. What it means is that you are trying to put in your design today what you might face or what you might plan tomorrow. You put the plans of your expansion now, which, if you remember, is the typical sustainability feature, to think about future generations to come and to think about what you may face in future. Now, why LEED is focusing on designing for flexibility for healthcare only? Because according to the research from REIT construction data, the hospital renovations and additions accounted for $4.65 billion in construction starting in 2009. Due to the highly sophisticated mechanical, electrical, and plumbing system, as well as HVAC systems found in the healthcare facilities, designs that allow flexibility for spaces can provide multiple benefits that range from financial and time savings to reduced resource use. Now, just think of a hospital where you have so many patients and you have the doctors working and they are providing the healthcare facilities to the community. And suddenly, because of your expansion or your plans, you have to stop it. But it should not be stopped anyhow if it is working. So you put these things in design in now so that you don't face these things in future. Now, designing for flexibility have these 8 options which LEED guides us on, and you have to implement at least 3 of them to get this credit. Now let's see one by one. Soft space, at least 5% of DGA. DGA is departmental gross area. You mean the gross area of the department of the hospital. Then shell space, interstitial space. We are going to see these in the next slide. Now let's see what is vertical expansion. At least 75% of the roof. If you see on the picture on top left corner, this is an actual hospital, an actual vertical expansion going on. 75% of the roof area. Now, you know, there are sometimes equipment you put on the roof. So if you have expansion in mind, you put these equipment either in one place, concentrated, that is in 25% of the area, or you put them, for example, outside the building. Sometimes HVAC equipment is put outside the building and you put louvers around. We saw one picture in the previous slides where they put louvers around the HVAC equipment in the hospital. So you can expand your hospital vertically and you not disturb below. So this is one of the flexible design. Second is demountable partitions. This is inside. When you have some offices and you have any sitting area, for example, and you have these demountable partitions. The purpose is that if you want to change any architecture of the space, or if you want to change any size of any room because you have now a new equipment in your hospital. So these demountable partitions are first easy to dismantle. Secondly, they are reusable. And third, they do not produce too much mess. It's easy to take them out and put them anywhere again together. So 50% for the applicable areas. Now, horizontal expansion is common. You might have seen some plans like the one in the top corner. Where you have the existing building and you propose that you can have future expansion in this dark blue areas, and you just have to break one wall and you attach the corridor and you continue to the next building, but you provide some connections for the utility like energy or cable. You leave the space for the cables and you are ready for any expansion or any new structure. Now this was horizontal expansion. Now future parking structure, because if you are expanding your capacity for patients or for visitors, then of course you have to extend the parking as well. So you could have 50% of existing on-grade parking capacity. Movable or modular casework and millwork, at least 50% of it. Now, you know, there are so many files in the hospitals, patient files and doctors files, and so much record to keep off. So this modular casework and millwork, which is basically just the woodwork, designed for a certain architecture, certain area. If they are movable or modular, means it's in the shape of the modules. We saw that modular structure is anyhow good for waste reduction. We just saw that. So it will reduce your reuse. For example, if you move to any other place, or you have reshaped your the architecture of your department, so these are easy to move, and they will be possible. It will be possible to fit them anywhere. Now let's see about the soft space, interstitial space, and the shell space in the next slide. So let's look at the definitions first. Interstitial space is an intermediate space located between floors with a walk-on deck. If you move into the hospital which has interstitial space, you might not be able to see it because it's above the ceiling. So it's like a floor in between the floor. If you look at the figure, what they place inside is, it's a complete height of a person who can move on to this walk-on deck, and you place the MEP systems, utility system like water heater, if there are all the HVAC equipment above the ceiling, and you can move on for maintenance. If the people who are in maintenance or in construction, they know usually these if you do not have a walk-on deck, these utilities or MEP systems are reached by small openings like 60 by 60 centi opening or 80 by 80 maximum for maintenance, and it's hard to go inside and to maintain your system or equipment. So if you have a walk-on deck, you can move along and you are not disturbing anyone. The things below are going as normal. So this is the purpose of HVAC systems, for interstitial space, that you can maintain, and it is easy to move on, and you do not disturb anyone below. Now let's see the soft space, an area whose function can be easily changed. We just for in a hospital, the main thing you have are the sensitive medical equipment. Around these medical equipment, you design your spaces. If you have an X-ray equipment, or if you have MRI equipment, then you design the space around like sitting areas, like the doctor's table and all the other required stuff around. But in case you need to change it, you do not change the equipment. You just in case you add another equipment. Now you have to make space for the second equipment in the same facility or in the same department. Now you want to expand the capacity, and you buy another machine. So you have to change the architecture of this department. This is called soft space, where you can change the function of an area. You just dismantle some demountable partitions, you change the desk and all the computers and stuff, you put the machine in. So any storage space, admin space next to highly specialized equipment is called a soft space. Now the shell space, an area unfinished left in existing building for future expansion. If you see in the figure, the room seems to be complete, only you do not have the ceiling, but you have the lighting, you have the MEP systems there, you have the access from the existing facility. So it's like an empty room, and you deliberately left it when in your design, that maybe we need it in future, or when, for example, certain equipment arrives, then we will put it there and we will use it for certain purpose. So this is interstitial, soft space, and shell space. Now for the documentation, you have to submit overall design strategy, what you are going for, how you are dealing with the future expansion. You have to submit 3, right? So you design your project as per these instructions, or as per these ideas, like to have a soft space, to have an interstitial space, or movable or model casework. So you will design your project based on this, and you submit this design strategy. And a calculation of departmental gross area, because it has to be shown in these spaces. Calculation of soft shell space, expansion capacity and future parking if you are going for that, and linear area of demountable partitions, and product cost of movable and modular case. So whatever you are implementing, these are 8 strategies. Whatever you are implementing, you have to submit the documentation for that. With that, we come to the end of materials and resources chapter incomplete. First, we discussed the part 1, which was applicable to all adaptations, and the second one is exclusively for healthcare. I hope that it helped you, and we will continue with the indoor environmental quality. Thank you.